This is 3D view of electrical transformer. Marshalling box. Radiators, fans, marshalling box. Nameplate details. HV terminals. Focalge relay. Conservator. LV terminals. Radiators. Cooling fans. Sampling valve. Drain valve. Support base frames. Magnetic oil gauge indicator. Emoji magnetic oil indicator. Breather. Nameplate details. Coming to basics of electrical transformer. This is auto transformer where single winding is used for both primary and secondary. This is also similar application. But the difference is here we have considered a circular core. Here we have considered a square core. Next to single phase transformers. Next three phase transformers. These are the laminations, silicon steel laminations. These are the holes provided for riveting or stacking. These are the cores, three phase cores. Each core is for one phase R, Y, and B. In case of three phase transformers, the same core setup can be used for single phase transformer. In that case, this type of arrangement is known as shell type, whereas HV winding and LV windings are placed on the central limb in a sandwich form. These are the various types of cores. This is completely square core, and this is cruciform core or stepped core. The advantage of cruciform core or stepped core is the windings are almost circular. Here the windings are in square form. Here the advantages will be less copper, less insulation, more utilization factor. These are the advantages of cruciform core. And these are the windings placed on the iron core. These can be either windings or conducting copper bars. This is for R phase, Y phase, and B phase. So on each limb, you will be having two windings. One is HV winding, another one is LV winding. So on same limb, HV and LV, both windings will present of one phase, R phase, Y phase, and B phase. In case of single phase transformer, the LV windings and HV windings, these two can be placed on two separate limbs, or 50% of LV winding and 50% of HV winding can be placed on each limb. This is the winding arrangement. LV winding and HV winding both are placed on the same limb. Limb is not indicated and insulations are also not indicated. But the arrangement is like this on each limb. So this is transformer core with three limbs, and windings are placed on all the three limbs. Next, adjacent to this iron core, there will be LV insulation. Next, LV winding. Next, HV insulation. And the next, HV winding. In this way, all the three phase windings are placed on all the three limbs, R, Y, B. This is wire drawing. Standard wires can be prepared. During this process, we have to remember only one thing, that is enamel coating. Enamel is a insulation material applied on copper wires. The temperature withstanding capacity of this enamel can be varied from 105 degrees to 400 degrees also, depending upon application. So in this transformers, only three things we have to mainly remember. One is transformer core. Second one is LV insulation and HV insulation. Third one is LV windings and HV windings. These three are important. So we will discuss basics of electrical transformers in detail in the following slides. Coming to basics of electrical transformer, this is overview of electrical transformer. Construction of transformer. This is transformer tank, body of the transformer, which is connected to earthing system at 2 points. And this is total internal of electrical transformer. One is insulation base on which the core is placed, and these are the windings, HV windings and LV windings. Proper clearance shall be maintained from the core of the transformer to body of the transformer. Similarly, proper clearance shall be maintained from windings to core as well as transformer body, because the transformer body is connected to grounding system. So in order to avoid the dead short circuit conditions, the windings shall be maintained clear distance from the body of the transformer. Similarly, winding shall be maintained clear distance from the core of the transformer also, in order to avoid short circuit conditions. So this is transformer core, silicon steel laminated transformer core. These are the cooling tubes or radiators. The type of cooling can be either naturally cooled or force cooled. In case of force cooling, fans are provided adjacent to the radiators in order to dissipate the heat very quickly. So why cooling is required? When the transformer is in operation, windings will carry load currents, and these windings will dissipate heat. The heat is being extracted by the transformer oil, and this is in contact with the transformer body and radiators. So the heat is being transferred to the radiators and transformer body. When the heat generation is more than the heat dissipation, then force cooling is required, else force cooling is not required. Transformer oil is application. It can be used as a coolant, and the same can also be used as a insulation also. Depending upon rating of the transformer oil can be varied from 800 liters to 8000 liters or even more. So that we have considered in kiloliters. Before connecting the supply to this transformer, these can be termed as LV winding and HV winding. After giving supply, these can be either primary winding or secondary winding. These are the terminal bushings or connections. So the general terminology for these terminals will be pressure relief valve or explosion vent. These are safety valves. The total transformer weight can be considered in metric tons. And this is a half circuit tap changer, which is provided on the top of the tank. It is provided in between HV and LV bushings. This is half circuit tap changer. When the transformer is not connected to the supply, then only this tap changer can be operated. Focus relay. This relay provides internal protection. If there are any internal faults within the transformer, such as core failure, winding failure, insulation failure, transformer oil, electric property failure, in this way, Bocal's relay provides protection, internal protection. This is conservator tank. This is provided on LV side of transformer. This conservator tank will reserve oil. Approximate capacity is 10 to 12% of total transformer oil capacity. There will be MOG, magnetic oil gauge indicator, provided on the one side of the conservator tank. On the other side, mechanical indicator is provided. During oil filtration process, the oil filling is done through this conservator tank and the drain valve, and the conservator is filled nearly 3/4 of the conservator tank capacity. So transformer conservator should be filled nearly 3/4 before charging this transformer. This is breather. Breather contains silica gel. Property of silica gel is it absorbs moisture during transformer breathing. When the transformer is in running condition, air goes in and comes out through this breather. If there is any moisture in the air, that can be absorbed by this silica gel. Silica gel is CaCl2. Silica gel changes colors from blue to pink. When it is dry, it is blue. When it is wet, it is pink. Once the color is changed to pink, then we have to collect the silica gel and we can heat the silica gel in oven so that the complete moisture can be evaporated and the color changes back to blue again, so that the silica gel is reusable. Reheat it and reuse it. When the transformer is in operation, gases are liberated in the transformer. Those gases are hydrogen gases. These hydrogen gases are collected in the top portion of this conservator. Temperature gauge. When the transformer is in operation, the approximate temperature will be 75 degrees when the transformer is operating nearly full load. As the load increases 110% or 120%, the temperatures of winding and oil will increase. Oil temperature indicator, winding temperature indicator. These are settings for alarm and trip conditions. For OTI, it is 80-85. If the oil temperature is reaches 80 degrees, then it will give alarm. If the oil temperature reaches 85 degrees, then it will trip the main breaker of this transformer, so that the transformer will be out of service. Similarly, for WTI, winding temperature indicator, approximate settings are when 90 degrees, it will give alarm. When 95 degrees, it will give trip condition. Valves, there will be number of valves provided on the transformer for inlet of oil, outlet of oil, top sampling valve, bottom sampling valve, and other protective valves are provided on the body of the transformer. So here only one valve is indicated, that is transformer outlet valve or drain valve. NGR, neutral grounding resistor. The transformer neutral can be connected to grounding system either through resistor, that is NGR. This is a separate enclosure provided within the transformer bay. OLTC, on-load tap changing. This is also separate compartment provided on the body of the transformer, which is attached to the body of the transformer only. NIFPS, nitrogen injection fire protection system. This is a protection system. It is completely through nitrogen cylinders, control panel and piping network going to the transformer and coming from the transformer. During fire condition, the transformers can be protected by injecting the nitrogen into the transformer oil. These are the important points with reference to transformer. Transformer is a static machine. There are no rotating parts. This is a passive device. On large scale, this is equivalent to a iron core inductor. This is very rugged machine. Operation and maintenance are very easy. This is a single excited machine. On only one side we are giving supply, on the other side we are receiving voltages. It provides electrical isolation between primary and secondary, as these two are magnetically coupled but electrically isolated. So the electrical resistance between primary to secondary is infinite. The transformer will transfer electrical energy from one circuit to another circuit. That means from primary to secondary, it will transfer electrical energy by changing voltage and currents, but the power and frequency, these will remain constant. This is on primary side and this is on secondary side. Primary can be considered as port 1, secondary can be considered as port 2. This electrical machine operates on electromagnetic induction principle. There is relative time variation. For voltage generation, either we can have relative space variation or we can have relative time variation. In rotating machines, we have relative space variation, where the rotor rotates and the voltages can be tapped from the stator. Whereas in case of transformer, the windings are stationary, but only the field is rotating. This is alternating field. The field is rotating in the core of the transformer and the windings are stationary. So as the field is rotating, voltages will be induced in the windings. So the transformer can be considered as two-port network, primary port 1, secondary port 2. From two-port network analysis, we can derive ABCD parameters for these transformers. The transformer can be considered as an amplifier. The secondary voltage either we can increase or we can decrease. That is step up or step down application. The secondary voltage is exactly 180 degrees phase opposition with reference to primary voltage. It is equivalent to negative feedback. Coming to applications, in power networks and distribution networks, we can use these transformers. The rating of transformers either MVA or KVA. Transformers as instrument transformers. These can be used for metering applications. Examples are CT and PT, current transformer and potential transformer. These are used for measuring current and potential of high voltage or high current circuits. In this case, instrument transformers will be having VA burden. Here the rating is not in KVA, not in MVA, but the rating is considered as VA burden. In maximum power transfer applications, such as in communication networks, we can use these transformers. These transformers used for impedance matching. From primary to secondary, the impedance can be matched for maximizing the power transfer from circuit 1 to circuit 2. In case of electronic applications, radios, TVs, transformers can be used for input stage transformers, output stage transformers, and intermediate state transformers. These transformers can be used. These are very low rated, very small sized transformers. In case of radar networks, pulsating transformers, these can also be used. Coming to important application, HV testing. During HV testing, these transformers can be used for high pot and BDV test applications. BDV is breakdown voltage test of transformer oil. High pot test, cables or switchboards can be tested for high pot withstanding capacity. High pot means high potential. Lighting transformers. These are 1:1 transformers. On the primary and the secondary, the number of turns will be same. This is 1:1 transformer. This is only to provide electrical isolation from primary to secondary. Supplies will be given only one side. On the other side, the lighting load is connected. This is lighting transformer. Lighting transformers, either it can be 150 kVA to 250 kVA or even 400 kVA also. These transformers will be having off-circuit tap changers. The coefficient of coupling between primary winding and secondary winding, the magnetic coupling or coefficient of coupling, it can vary from 0 to 1. So these are the important applications of electrical transformers. The main application of transformer oil is for cooling and insulation. Properties of transformer oil: low viscosity, low velocity, high heat transfer capacity, high flash point, it shall be more than 135 degrees Celsius. If the oil temperature exceeds more than 135 degrees, then the transformer oil will become conductive. That means dielectric property of that oil is failed, so that it became conductive. Breakdown voltage test of transformer oil. To perform this test, we required this arrangement. One is glass bowl with two electrodes. These two electrodes are separated by 2.5 mm gap, and these are 12.5 mm rods. Transformer oil, single phase voltage, variable transformer. The voltage can be varied from 0 to 80 kilovolt. The transformer oil is collected and BDV test is performed. If the BDV result is lesser than 30 kilovolt, then this transformer oil is not suitable for service, and we have to completely fill the transformer with new oil. And again, the BDV value is checked. If the value is more than 30 kV, then it can be used, but the recommended value is 70 kV. If the value is lesser than 70 kV, then we have to go for oil filtration process. During this filtration process, if there are any sediments and impurities in the oil, those can be filtered out, and the BDV value of this transformer oil can be improved. During this process, the transformer oil is heated approximately 50 degree. In this way, the transformer VDV test must be done before and after filtration. During oil filtration process, the oil temperature shall be maintained lesser than equals to 50 degree. If we increase the oil temperature, then the BDV value will be lesser than 70 kV. For example, if the oil temperature is 50, then the BDV value is 70. If we increase the oil temperature to 70, then we may get approximately 50 kV. So the oil temperature and the BDV are inversely proportional. We should not increase the oil temperature more than 50 degree during oil filtration process. If the oil temperature increases such as 55, 75, 85, 135. 135 is the flash point of the transformer oil. That means if the oil temperature is 135, the transformer oil will be equal to a conductive path. So the oil temperature and BDV values are inversely proportional. Bushings. The transformer windings are brought to these terminal bushings. These terminal bushings can be of porcelain material if the operating voltage is lesser than or equals to 33 kV. If more than 33 kV, that means more than or equal to 66 kV, then the bushings can be either oil type or capacitive type. Shape and size shall be selected in such a way that stresses and corona will not occur on these terminals, and these terminals are suitable for indoor and outdoor applications. Focus relay can be provided for transformers more than 750 kVA. This mainly provides protection from internal faults. Internal faults such as core failure, winding failure, and insulation failure. This is a gas-based device. During faults, gases will rush towards the conservator from the main tank. Based on the intensity of the flow of gas, the mercury switches will operate. There are two mercury floating switches. One is for minor operations, one is for major operations. Sensitivity is adjusted such that if the flow of gas is low, then it will give only alarm condition. If the flow of gas is fast, then it will give trip condition. These are only gas flow based floating switches. So during minor faults, only alarm will be provided, but during major faults, alarm plus trip both will be operated. Cooling of transformer. Depending upon rating of the transformers either naturally cooled, either force cooled. Lesser than 1.5 MVA, these transformers are air natural cooling. Up to 3 MVA, oil natural ON. As the transformer rating increases, type of cooling arrangement also increases. ON, AN, oil natural and air natural. OF, AF, oil forced and air forced. For these, pumps and fans provided on the radiators. For higher transformer, NIFPS, nitrogen injection fire protection system. This arrangement system is provided along with nitrogen cylinders and control panels, piping network going to transformer and coming from the transformer to this control panel. During fault conditions, this control panel releases the nitrogens from the cylinders into the transformer tank, and the transformer is rapidly cooled down. In this way, the transformer can be protected from the high fault conditions. Spacers are provided between windings for cooling conditions. These spacers are not provided for core. This point we have to note. So that when the spacers are provided between the windings, oil can be passed through these spacers and winding through windings, so that the heat can be extracted easily from the windings to the transformer oil. So these are the applications of spacers. So in this way, the transformer cooling can be provided. Representation of transformer. This is HV winding and this is LV winding. This is the core of the transformer. This is a three-phase transformer. The primary is delta connected, the secondary is star connected and the star is solidly grounded. This is supply given to the transformer. When the supply is given, this is termed as primary and this is termed as secondary. The supply is not given, then these can be termed as HV windings and LV windings. This is OLTC, on-load tap changer. The primary is delta connected, secondary is star connected, where the star is solidly grounded. This is transformer with OLTC, on-load tap changer. Vector grouping of transformer DYN11. Capital D is with reference to primary, small y and N is with reference to secondary. As the secondary is star connected and the neutral is connected to the ground, so it is YN. 11 is with reference to leading and lagging of voltages from primary to secondary. This we will discuss during connections of three-phase transformers. If delta and star connections are not indicated, then this is a two-winding transformer. The two windings can be LV winding and HV winding. This can be single-phase transformer also, or this can be two-winding transformer. So these are the important points with reference to basics of transformer.